In this video, we will learn about propagation of sound. So we know that sound is produced by vibrating object and it moves through a medium from point of generation, that is from the source it is generated, let's say a drum or a musical speaker or instrument, to our ears. Okay, that is the listener's ear. Now, the medium through which the sound is propagated can be solid, liquid, or gas. So we know that sound energy cannot travel through vacuum. That is why in outer space, astronauts cannot hear each other normally via environment. They use microphones. Okay. Now, without the presence of material medium, that is vacuum, we cannot hear sound because sound energy cannot travel through vacuum. Now, to demonstrate this particular trait that sound cannot travel through vacuum, we perform a simple experiment. Okay. Now, the material we require is a bell jar like this, an electrical bell, a battery that is here, now a switch and a vacuum pump. Okay, now the procedure is that we take a airtight bell jar like this and we suspend an electric bell inside the bell jar as you can see in this particular figure. Now the electric bell is connected to a battery and a switch which can be operated outside the jar. Now, the bell jar is connected to a vacuum pump like this. Now, when we switch on the bell, we are able to hear the sound produced by the bell because we still haven't used the vacuum pump. So there is air inside it, that is environment is there inside it. So sound energy can travel through it. That is why we are able to hear it. Now, when we start the vacuum pump, as the air from the bell jar is pumped out gradually, sound by the electric bell becomes fainter and fainter. So, suppose this was the level of sound before, now it will become low, low, and low as the air is escaping the particular bell jar. Okay, now still we can say that the sound produced by electric bell becomes fainter although the same current is flowing through the bell jar. Now the level of sound is falling as the air is escaping the bell jar, but still the electric current it is getting is same. Okay. After some time, when very less air is inside the bell jar, we can hear a very feeble sound. Okay. Now, if the air is completely removed from the bell jar, then we are not able to hear the sound of the bell, although it is still ringing. Now, when we disconnect the vacuum pump from here and we let the air enter the bell jar, then again we are able to listen to the sound of this particular bell. The conclusion we get from here is that sound cannot travel through vacuum and it requires a material medium, that is air in this particular experiment for its propagation. Now, the method of propagation of sound through a medium. So when an object vibrates, let's say a bell is vibrating. Okay, so this is a bell and it is vibrating. The medium particle do not travel all the way from vibrating object to our ear. Now this is the medium particle. Okay, this is one layer, this is second layer, this is the third layer. Let us suppose that sound energy is coming from here. Now these particles will vibrate in their own place. Now this will make this particular vibrate here and this will make this particular vibrate here and this thing will happen all the way to our ear. A particle of a medium in contact with a vibrating object is displaced from its equilibrium position. Then it exerts a force on the adjacent particle, that is the particle near it, like this. Okay. Now, the adjacent particle get displaced from the equilibrium position. After displacing the adjacent particle, the first particle of the medium comes back to its original position. And this process of transfer of disturbance from one particle of medium to the next particle and so on continues till the medium particle just near our ear starts vibrating the sound, that is the disturbance reaches our ear. Now we can say that the disturbance created by a source of sound in a medium travels through the medium particles, but there is no bodily motion of the medium particles. Now to understand it more clearly, let us suppose this is the medium particle and this is also medium particle. This is also medium particle. Let's say this is first particle, second and third particle. Our ear is over here and this is our source. Okay. Now the source will make the first particle vibrate in its own place. Now this, when in contact with the second particle, will make this one vibrate and then in turn the third will vibrate in its own place. Now, particle is not moving from here or to the ear, but it is making the adjacent one to vibrate. And likewise, the last particle will make the eardrum vibrate, and hence we can hear the sound from this particular source. Now, again, we can say that this is our ear and this is our source. Now, this is first particle, second, third particle, and so on. Now, what happens is the medium particles simply vibrate to and fro about their respective equilibrium positions, and the transfer of disturbance or transfer of energy to the adjacent particle like this happens. Okay. Now, in this way, disturbance propagates from source of sound to the listener, and this method of propagation of disturbance, that is sound energy, is called wave motion. And we know that waves which require a medium or a material medium for its propagation is called a mechanical wave. So this is the definition of mechanical waves. Thus, we can say that sound energy travels through a medium, let's say air, as mechanical waves. I hope this topic is clear to you. Thank you.